We are looking at chapter 13 of class 11, and the chapter is limits and derivatives. So what is limit and derivative? Why would we require it? This is actually the introduction of calculus, and how calculus is so popular, why you learn it in class 12th and later engineering and other aspects. So the thing is that the mathematics here is how a function changes with the value which is given to the function. So the behavior of the function is what we are going to see in the calculus, and there are so many things which are related to it. We'll talk about the limits also, and we'll talk about the algebra of derivatives, the definition of derivatives, etc. So the intuitive thing is, if there is a cliff, now you are throwing a ball or say a rock from the top of the cliff or a hill. Now the main thing is that when it is coming down or when it is rolling down, then what happens? How does the speed or the acceleration or the velocity of this particular stone or a ball changes when it comes down? This is what we are going to see. Please understand what I have spoken. I have spoken velocity also, which is the rate of change of speed. Velocity is rate of change. The rate of change is nothing but the derivative. Okay. So let us take an example that if s is equal to 4.9 t square, s is the distance traveled and 4.9 is some constant and t is the time. So t is the time means if some time, say place 2 here, you'll get a distance it will travel. You place t equal to 3, so you will get a distance it travels in 3 seconds or 4 seconds, whichever value you place here. So what is the thing? Now at this point and this point means, say t equal to 0 you sent it, and this is t equal to 3, this is t equal to say 2. So now you are able to find out with this particular equation from t2 to t3, t2 to t3 also you are able to find out what was the speed or what was the distance being covered. So how you are going to find out? Let us take that from 0 to 2 how much it traveled. From 0 to 2 the distance traveled is, we can place it 4.9 t square. So t equal to 0, s equal to 0, t equal to say 2, so you'll get t equal to 2, you'll get s equal to 19.6. Place 19.6 here and 0 here, and speed is equal to distance by time. So we'll use the basic formula here, and this t1 is 0 and t2 is 2. At 2 second we need to find out. So this is what 9.8 meter per second, right? Now the average velocity between t equal to 1 and 2 can also be found out by this table. We are just placing different values of t so that we can get the value of s here. Okay. So what we are getting here is, for certain t values we are getting velocity. But here is a question. That from t equal to 2, the value was, we just found out the value. What was that? The value was 19.6 was the distance traveled, and the velocity also, see, t equal to 2, the velocity was 9.8. Okay, or say t equal to 1 to 2, the velocity was this. Now what happens here is that the time when it is varying from say 1.95 to 1.99, there is not much variation, but there is still some variation, but not much variation, still variation. But if I say that 1.99 to 2, if I place value here 2, and I wish you to find out the value of v, then the value of at 2, t equal to 2, the velocity is not going to change much. That is, there will be no dramatic change. This is what we are talking about. We are talking about the values when the time are changing like this. Okay, 4 to 3 it's considerable change, but when we say 2.05 to 2.1 or 2.05 to 2.01, there is no dramatic change. There is still change, but not a dramatic change, right? So this is what we are saying, that even if you go from 1.99 to 2 and you say from 2 to 2.01, the velocity, say if it is v, then it will be v plus some x and v some minus x, say, but it will be say v minus x and v plus x. This x will be very small, very small. There will be no dramatic change here. So what we are trying to find out, we are trying to find out the velocity, which is the rate of change of distance. The rate of change of distance is the derivative. So when we are dealing with the derivative, we are actually finding out the rate of change of anything. So whenever some derivative comes to you, just understand, because you know what happens when I was learning, I was in 12th and I was not even knowing what derivative. I was able to solve everything with respect to derivative. But what exactly derivative? The question is that if you understand derivative, then only you can appreciate the questions there. So derivative is what? Derivative is actually the rate of change of anything. How the rate at which that particular thing changes. May be infinitesimal small, may be very large. The duration. Okay. Now what I want to tell you is that at t equal to 2, see, this was our equation. This was a line t equal to 2, and now these two lines, please consider these three lines. Okay, actually we are binding something. So the black one, this black one is our curve. Okay, this curve, what is happening here is, in this curve we are trying to find out, this is a tangent, or this is the values which are coming at certain point, at say 1.99, say 2 and 2.1. But what we are interested in, because derivative is nothing but d by dx of some value, or d by dt, or any differential you can take, so that is the rate of change. So how rate of change means this one by this one, this one by this one. Okay, so what we are saying here is c1 b1 by ac1, c2 b2 by ac2, c3 by ac3. These are all your derivatives. These are nothing but the derivatives. Okay, now coming to the limit part. Limit, it came from derivative that 1.99 and 2. So this value is approaching 2. 1.99 is exactly not 2, but it is equivalent to 2. So it is approaching 2. So we are saying that 1.99 is tending to 2. Tending to 2. It is going to 2. So the limit is nothing but, actually limit is what? Basically what happens here, that you say 1090. 1090 is what? It is infinite. How to find out value at 1090? 1090 is undefined. So if you want to find the 1090 here, the graph is like this. You want to find out the value here, but you know that there is no value here because it is undefined. But you can find out the value with just closer to it, and you can say, okay, this will be the value here. What I'm saying is, the value at 2 is not possible, but one value at 1.99 is possible. If it is possible, you can say that it tends to it, and you can find out the value at this point. So if just take an example, if fx is equal to x square, and x is very close to 0, and we say that fx limit x tends to 0 is 0. You place it here, fx is x square. I place x equal to 0. So 0 square is what? 0. So x tends to 0 means if x is placed 0, so x square will be 0, right? So what we are saying here is some limit, or limit which is the value which it is approaching. And essentially we are interested in finding out those values or those points which are not defined, which are undeterminate, which we cannot find. So the best way is to find out the limit. If you have a function like this, say hx is equal to x square minus 4 by x minus 2. If you place x equal to 2 here, this will give you answer as 0 by 0, which is incomprehensible in our case. We cannot have this value. So what we can do here is, we can just solve it in some way, so that we can get the value which is nearer to it. So we say limit x tends to 0, x tends to 2 in this case, and x square minus 4 can be written as x minus 2, x plus 2, and this x minus 2, this gets cancelled out. Now x equal to 2, you place 2, this will be 4. So you are actually getting value, otherwise you will get 0 by 0. So this is how we are talking about the limit. So how we write it? We write it like this: limit x, or any value which tends to that particular value, means x tends to 2 or y tends to 10, like this, and then the function. Let us take one more example. Before that, let me tell you that 1.99 in the previous example, 2 and 2.01. So this is our left limit, this is our right limit, and this is our actual value where it is not defined, or say even if it is defined, then this is the left hand limit, this is the right hand limit, left hand limit, right hand limit. So limit, if left hand limit becomes equal to right hand limit, then we say the limit of this exists. If left hand limit and right hand limit are not equal, then we say limit does not exist. Let us take an example. Fx is equal to 1 for x less than equal to 0. Fx is equal to 2, x greater than equal to 0, or greater than 0, not equal to, greater than 0. So then this, if we write limit x tends to 0 minus, this is 0 minus. Why this minus? Because we are taking a value which is just approaching 0. It is less than 0. So when we are placing x which is less than 0, we know that if x is less than 0, the fx is going to give you 1. So this is 1. Now if x is getting higher than 0 value, means 0 plus, x tends, if limit is x 0 plus, the function is giving you value 2. So this left hand limit and right hand limit, they are not equal. So we say that limit does not exist. How and what is the logic behind it, or the idea is that this and these are two different functions. They are not continuous. They are not continuous. If it would have been like this, then it would have been possible that the limit exists. But in this case, it doesn't, because they are different. They have break, and if break is there, then you will not have a limit. So let us summarize it, that if you have a limit x a minus on the left hand side, we call it as a left hand limit for some x equal to a. And if x equal to a and we write x tends to a plus, that is, we are talking about the limit on the right side, in the right side. So if the values are similar, we say that okay, limit exists, otherwise not. We'll take certain examples. Illustration 1 is fx is equal to x plus 10, and we want to find the limit at x equal to 5. So 5 is there. Let us take some values which are lower than 5, some values higher than 5. So the values which are lower than 5 are like this. A value higher than 5 are these real numbers, 5.001, 5.01, and like this. So let us find out the value. The value, we see that there is no dramatic change from this point to this point. Not dramatic. There is a change, but there is no dramatic change. So we say that the value at x equal to 5, the value at value less than 5 will be lower than value which is over 5. Okay. So let us in x plus 10, let us place the value as 5. So actually it was x plus 10, so place it as 5, so it will give you 15. Right? So if x approaches 5, this is also equivalent to 15, this is also equivalent to 15, and since the left hand limit also exists, right hand limit also, 5 minus 5 plus, also exists, and both are somewhat equal to 15, we say fx is equal to limit x tends to 5, fx is equal to 15. Then let us take one more, x cube. Place value which are, because we have to check at x equal to 1, place value which are less than 1 and greater than 1. So these are values, these are less than 1, these are greater than 1, greater than 1, less than 1. Now place the value, let us see what you get. You get x 1 minus means less than 1, you get 1, near to 1. And when you go above 1, you also get 1, which is near to 1. So the left hand limit and right hand limit, they are equal to the actual limit. So this is how this function is actually showing you that at x equal to 1, there is a limit of this function. Let us take fx equal to 3x. 3x for x equal to 2. So take value which are less than 2. Take value which are greater than 2. And see, the values are not changing dramatically. So this x tends to 2 minus, x tends to 2 plus, both are giving you the value as 6. Every time you are getting somewhat 6. So we have the limit. It actually gives you a limit. Now constant function fx equal to 3, and we have to find out the limit at x equal to 2. Constant function will give always this value 3, whichever value you place. So even if you place 2 minus or 2 plus, you are going to get the value as 3. So left hand limit and right hand limit and the actual limit gives you the value 3. So this is also the limit exists. Well, there is no question of limit because it is a constant function, but still. Now consider this function fx equal to x square plus 1, x square plus x. We have to check it near 1. So what, there are two ways. Either you can check them separately, or you can just add them, or you can write x square plus 1 as x plus 1. So there are various things which you can take. X equal to 1, so take value which are less than 1, greater than 1, and you always see that there is no dramatic change in x square plus x. So in this case also, but one thing you need to know, that this x square plus x can be taken as x square plus x, x plus 1, or individual also, and they are going to give you the similar value. One more function is this fx is equal to sin x, and we are interested in limit x tends to pi by 2 sin x. So let us take values which are less than pi by 2, which are greater than pi by 2. Even if you take less than pi by 2, you are getting the value as 1 only, almost 1. Even if you take value which are greater than pi by 2, that is 90 degree, you are getting similar to 1. So in both the cases, limit x tends to pi by 2 is 1 only. And this is supported by the graph also. If you have x plus cos x, there are two ways. First, you can take the limit of x, take the limit of cos x, left hand side, right hand side, and then add. Or rather, you can directly place the value at x equal to, say, 0. So these are the value less than 0. These are the value which are greater than 0. So 0 minus also give you 1. 0 plus also give you 1. So here you see that the value gives you 1. So this is indeed true and limit exists. Then let us take this function fx is equal to 1 by x square. Now what it says, at x greater than 0. Because if it is not greater than 0, then this will be 1 by 0 square, which is not acceptable, right? So what you are going to do here is, any value you take greater than 0. So it can be 1, 0 0.1, 0 0.001 and 10 to the power minus 1. Any value you can take. So the value which you will get is infinity if it tends to 0. So in this case, we do agree that if certain value is given here, this is going to give you indefinite value or indeterminate value, which is not acceptable to us, and we will try and solve in this expression in such a way that you can be able to get the limit. Right now fx is giving you infinite. Now this in the first go or in the first view, it seems to be degenerate. Degenerate means there are three different functions. So you can anticipate that this will not be able to give you the limit. But let us see. So we have to check it near 0. So let us take values less than 0 and greater than 0, because this is x tends to 0. So let us take what value it gives. So if you take 0 less than 0, so you get value as these values. Higher than 0, you get these values. And you see that at less than 0, it is giving you minus 2. Higher than 0, it is giving you plus 2. So minus 2 and 2, left hand limit is not equal to right hand limit. So the limit doesn't exist. The limit of the function at 0 does not exist, right? Because it is not a continuous function. One more illustration is there. Fx is equal to x plus 2, where x not equal to 1 and 0 x equal to 1. So you might be thinking that these two are different functions, so will not get any limit because this is not continuous. But let us take value less than 1, means all those values less than 1 and greater than 1, and place these value here. Okay, when you have equal to 1, you are getting 0, but when you are having x not equal to 1, you are getting x plus 2. So you are getting 2.999, 3.001, which are equal to 3. So it is actually giving you the value. So left hand limit and right hand limit are actually 3. So this is at this particular point x equal to 1, the limit exists, and the graph shows like this. Because this is a straight line, you are getting x plus 2. Y is equal to x plus 2 is a straight line, and you are getting a value limit because it is a continuous function. It is not degenerate function. So algebra of limits we are going to take shortly in the next discussion. Till then, this was an introduction to derivative and the limits. Thank you so much.